Hey guys, welcome. So today we're going to look at inductors and what are inductors and also solve some problems. All right, so let's get to it. Inductors is just an electrical component and it stores electrical energy in the form of a magnetic field. And what an inductor basically is you have a piece of conductor and it's just wound in circular turns. So this is actually the electrical symbol for an inductor. So you just take a piece of conductor and you wind it. Usually this winding is done around an iron core. So it's iron core is something just like a piece of iron. So you have a iron rod or something like that. And then if you just wind your conductor, usually your copper wire around it, so that becomes your inductor. So the construction is pretty simple. So how does the inductor store energy is when you have current flowing in these turns, it's going to create a magnetic field. And that magnetic field is going to oppose the change in current. So if I hook this up to, I'm just going to draw a box right here just for explaining this. So if I hook this up to a source, and this source has varying current, so this current is going to vary with time. So if the current keeps increasing, this inductor is going to have a magnetic field, and this magnetic field is actually going to oppose the flow of current, and it's going to do this by developing a voltage. So if this is the negative supply and this is the positive supply of the voltage source, and the voltage or the current keeps increasing, the induced voltage is also going to increase, and this is going to oppose the change in current. So that is an inductor. If you have a change in current flowing through the circuit, the inductor develops a voltage across it that is going to oppose it. All right, so let's understand it a little bit better. So here I have drawn out AC versus DC. All right, so as we saw before, an inductor opposes the change to the current. So in my DC case, I'm going to write it just here. In DC, the current change with respect to time is 0. So what I mean by that is you are going to have a constant current. So if there's a constant current, we saw here the inductor is not, there's no change in current, so there's also going to be no opposition. So in a DC case, the inductor is going to behave like a closed circuit. But in the case of alternating current, this is not the case. It's not equal to 0. So your current is going to keep changing, something like that. Because of that, inductor opposes the flow to alternating current. But just remember, this is not a perfect open circuit. It's not going to be perfectly open, but it is almost equivalent to an open circuit. So that is how an inductor behaves in an AC circuit. All right, so let's dive into that. And I have some formulas and we're going to look at it. All right, so I have here a sine wave, a current source that is sinusoidal, and the voltage for an inductor is given by the expression inductance times di by dt. So what it means is if you go to your inductor diagram, there's going to be an induced voltage. So this voltage is known as induced voltage. And this induced voltage is directly proportional to the change in current. So if I didn't have the equal to sign here, I could just write it as, so the faster the current changes, the more the voltage is induced, the higher the voltage. So if I want to remove this sign and put an equal to sign, I gotta have a constant that relates to it. And this constant is known as inductance. So resistors have resistance, capacitors have capacitance, and inductors have inductance. And usually if you have just a piece of conductor wound around a coil or just around air, the core is air, there's a formula for inductance, but we're going to look at it later. So let's go ahead and solve this. So my voltage induced is going to be L times differential of I sine omega t with respect to time. And this is going to be equal to L times. So I'm going to do the differentiation now. I'm going to get the constant term out, and the differential of sine omega t is omega times cos omega t. Alright, so the voltage induced in an inductor is omega times Li cos omega t. I'm just going to put this in bracket. Alright. So you see, if you have a current source that is a sinusoidal wave, that is a sine wave, your voltage that is induced, this voltage across the inductor, is going to be a cosine wave. So the voltage is going to lead the current. So our phasors are going to look somewhat like this. So this is going to be our voltage phasor, and this is going to be our current phasor. So there's going to be a 90 degrees phase difference between the voltage and current, because that is the phase difference between a sine wave and a cosine wave. So this is, let's say this is our current wave, and our voltage is gonna peak before the current, sort of like that. So it's gonna peak before that. Alright, so let's look at some of the formulas, and before doing that, I just want to bring your attention to this part right here. So we have our expression for voltage, induced voltage, and also for the current. So if I just go ahead and write this down, so an induced voltage is omega times Li cosine omega t, and the current is just going to be I sine omega t. Now if I'm taking up the time concept out of this, if I'm taking the time dimension out, and I just want to find the opposition, it's going to be Ohm's law. So that's, the opposition is known as reactance. Alright, so this reactance is, raise that a little bit, is nothing but V by I. So it's going to take the peak, we're just going to take the peak value, which is omega times Li by I. So if I cancel out I and I get my reactance, which is denoted by XL, is omega times L. So this is my reactance. This is my inductance. So this is the opposition. So resistance is not depending on this term. So this is 2 pi f, angular frequency. So if you have a sinusoidal waveform and you're applying a sinusoidal current, the voltage is gonna lead. So the voltage is gonna lead by 90 degrees, and the opposition is called reactance, and that is omega times your inductance, omega times L. That is it, guys. So let's review from the top. An inductor is just a piece of conductor, usually a copper wire, wound around a core. And this is sometimes iron core, sometimes it's just air core, and this conductor has to be insulated when it's wound. And the way it operates, it opposes change in current. Alright? So inductor operates by opposing the change in current flowing through it. And if you see the behavior of an inductor in an AC circuit, it behaves like an open circuit. In a DC circuit, it behaves like a closed circuit. And we also looked at if you have a sinusoidal wave, a sine wave current source, and we looked at what is inductance, which is a term that relates the induced voltage to the rate of change of current. And we also looked at what is the phase difference between the voltage and current of an inductor. And we also saw what is the reactance. All right, so let's go ahead and solve some problems right now.